Hello my dear children, in the class of electronics we are going to study applications of diodes, and the very first application of diode is rectifier. So what are rectifiers? Children, rectifiers are the devices which convert AC into DC. Alternating current or alternating voltage is converted into direct current or direct voltage. Well, all rectifiers are of two types. Well, rectifiers are either half wave or they are full wave. So half wave rectifier and full wave rectifiers are the two different types of rectifiers. Children, before we study this rectification, the conclusion we made in the last class with regard to biasing of diode is very important and is going to be used right here. And if that conclusion is not in our mind, we won't be able to understand rectification. So let us recapitulate the conclusion we made in the last class with regard to the biasing of diodes. Well, when P side of the diode is connected with positive terminal of the battery, PP, or N side of the diode is connected with negative terminal of the battery, diode is said to be forward biased. PPNN. This P is the P side of the diode and this small p is the polarity of the DC terminal. N side of the diode is connected with negative polarity of the DC terminal. Well, in this case the diode is said to be forward biased, and when the diode is forward biased, it conducts. This is diode. This is P side, this is N side. This P is connected with the positive terminal of the battery. This N is connected with negative terminal of the battery. Diode in this situation is going to conduct and the current is going to flow like this. Otherwise, in reverse bias, diodes does not conduct. So what is reverse bias? Reverse bias is just opposite of this. P side of the diode when connected with negative, or N side of the diode connected with positive. PN or NP. This P is the P side of the diode connected with N, the negative polarity of the DC source, or N side of the diode connected with positive polarity of the DC source. Diode is reverse bias, and in this case the diode does not conduct. Well, this is diode, this is P side, this is N side. If P connected with negative, N connected with positive, the diode behaves like an open circuit, it does not conduct. Children, let us understand the circuit diagram of half wave rectifier and full wave rectifier. So what is the circuit diagram? See, this is transformer. This is nothing but the diagram of a transformer. And this transformer is connected with what? Alternating source. This is AC source. This is input. I/P simply means input. So input is connected across the primary of the transformer. This is alternating current, and the secondary of the transformer, secondary coil of the transformer is connected across the diode, and this diode is connected with load, and across the load we get what? Output. O/P stands for output. So what is that output? We'll know it very shortly. Well, in full wave rectifier, this is alternating source. As usual, this is transformer, this is input AC, and this input AC is time varying current with respect to time. This is time varying current varies with respect to time sinusoidally. So this is input I/P connected across primary of the transformer, and this is secondary of the transformer, and secondary of the transformer here is connected with two different diodes. In half wave rectifier we have just a single diode, but here we connect a diode here, we connect a diode here. Both the diodes are short to each other, that is connected to each other, and then from common terminal we connect load, and the other end of the load is connected with C. C is central tap. It is a variable knob which moves over the secondary coil. So C is the central tap. It moves all over this secondary coil, and we get the output across the load. Children, let us understand the working of half wave as well as full wave rectifier. Well, this is input. This is input waves, that is alternating current, time varying current. This is input wave and this is alternating current. And what happens, children, when this type of source is connected across any terminal? Well, the polarity of the terminals are reversed after every half, that you have already studied in AC. When alternating source is connected across any terminal, the polarity of those terminals reverses after every half the cycle. Or we can say the polarity of the alternating source terminals is reversed after every half cycle. This is first half, this is positive half, this is negative half, this is positive half, this is negative half, this is positive half, and then negative half. So in one half, one end of the terminal would be positive and other end of the terminal would be what? Negative. And in the next half, the polarities are reversed. Again in the next half, the polarities are reversed. So after every half cycle, the polarities of alternating source terminals are reversed. So we have connected here what? An alternating source. Say in the first half, this is first half. Say in the first half, well, this end is positive and this end is negative. This end has positive polarity, this end has negative polarity. Then what will happen? This is P side of the diode, this is N side of the diode. In the first half, when this end is positive, this end is negative, what will happen? This P is connected with positive. This P side of the diode is connected with positive in the first half. That means this diode is forward bias. And when the diode is forward bias, it is going to conduct like this. The current is going to flow through the diode from P to N side and it is going to flow like this. So current is going to flow for first half of the cycle. Yeah, this is the current we get. This is the current we get across the load in the first half. For first half of the alternating current, there is current across the load. But what happens, children? In the next half, the polarities are reversed. This end which was positive becomes negative and this end which was negative becomes positive. So in the second half, when polarities are reversed, see this P is connected with what? Negative terminal of the battery, Pn. Diode is reverse bias, and the diode is reverse bias means it is not going to conduct. It is going to behave like an open circuit. So the current in the circuit is what? Zero. This is the current. Again in the positive half, this end becomes positive, this end becomes negative, diode is forward bias and the current flows through the diode like this. So for every positive half cycle, there is current, and for every negative half the cycle, there is no current. Why? For negative half, the diode is reverse bias and the process continues. So this is half wave rectified output waves. And in full wave rectifier, yeah, there are two diodes D1 and D2. Again, as usual, polarities of the terminals of alternating source are reversed after every half cycle. Let us assume that this end is positive and this end is negative in the first half. If this end is positive, this P of the diode is connected with positive. This simply means this diode is forward bias. But look at this diode. This P is connected with negative. This P connected with positive, PP, it is forward bias. This P connected with negative, P, and this diode is reverse bias. That means this diode is going to conduct, this is not going to conduct. This diode is forward bias, this diode is reverse bias. This diode is going to conduct, this diode is not going to conduct. And when this diode is going to conduct, the current is going to flow like this from P to N side. Yeah, the current will flow like this, like this, like this, like this. The current would not move in this direction because when it is conducting, this is open circuit. The current will turn its way like this. The current will turn its way and it will flow like this. The current flows from P to N side and the path it follows is what? Like this. Why the current doesn't move this way? Because it is open circuit, it is reverse bias, it is not conducting. And see, the moment polarities are reversed in the second half, the moment the polarities are reversed, the current is obtained across the load from right to left, and this is what is the output in the first half. And remember, this output is because of diode D1. And in the next half, when the polarities are reversed, this is going to become negative, this is going to become positive. See, the moment this terminal is going to become negative, what is going to happen? This P is connected with negative terminal of the battery, P connected with N, this is reverse bias. But look here, this P is connected with positive. This simply means this diode is forward bias. In the next half, this is reverse bias. When this diode is going to be forward bias, it is going to conduct. And when diode conducts, current flows where? Current flows from P side to N side. Yeah, the current flows from P side to N side, and it flows like this, it moves like this. It won't move in this direction because this diode is not conducting. This diode is not conducting. It turns its way like this, and the circuit is completed like this. See, for the second half, current is again passing through the load from right to left. Current is again passing through the load from right to left, but this time it is because of diode D2. So this is output current through the load in the same direction, but because of diode D2. Again, when the polarities are reversed, this diode is forward bias, this diode is reverse bias, and the current flows through the diode. Yeah, the current flows through the diode because of diode D1. So every positive half, corresponding to every positive half, the current flows because of diode D1, and corresponding to every negative half, the current flows because of diode D2. So this is, all these are the currents because of diode D1, and in between for negative halves, the currents are because of diode D2. So this is half wave, this is full wave rectified output waves. So children, the output we obtain across full wave rectifier is connected across a filter circuit. So filter circuit is used to convert the alternating current, the output current which we obtain across full wave rectifier has a lot of ripples. It is DC only in sense that the current doesn't change its direction. But DC current is what? A steady current like this. So how do we convert this current which has a lot of ripples into a steady current? This conversion is done with the help of pi filter. This is a very popular filter. In this filter we have what? Two condensers connected in parallel to each other in parallel combination, and this is what? An inductor in between. So output of full wave rectifier is connected across these two terminals 1 and 2, and across these terminals 3 and 4 we obtain steady current, and that's how an alternating current is completely converted into pure DC. Children, these rectifiers which we have just studied have widespread application these days. Every electronic device operates with a DC voltage of say from 1.5 volt to 12 volt. Every device made using these semiconductors like diodes, transistors or ICs, they hardly require DC voltage of say from 1.5 volt to 12 volt at the most. So how do we don't get DCs these days. DCs are not produced by any generator these days. We have ACs all around. So what do? We convert that AC into requisite DC with the help of these devices called rectifiers. So every electronic device has a unit called rectifier in the power system of that particular unit. Eliminator, battery eliminator you use in your physics lab. So what is there in the battery eliminator? In battery eliminator we have what? A step down transformer. That step down transformer converts 220 volt AC into what? Say 12 volt DC. But that 12 volt DC which is obtained using full wave rectifier has a lot of ripples in it, and we get rid of these ripples with the help of filter circuit, and then we get pure DC of 12 volt. Well, in eliminator there is a knob, and with the help of that knob we can vary the voltage, output voltage we obtain, and that knob indicates voltage from 1.5 to 12 volt, and that variable knob is nothing but the central tap of full wave rectifier. This central tap moves from one end of the secondary coil to other end, and in the process the output voltage we obtained varies from 1.5 volt to say 12 volt DC voltage. So with this, children, we come to the end of our class of rectifiers today, and in the next class we will study 3 special diodes, and these 3 special diodes would be what? LED, photodiodes and solar cells. So this is all for the time being. Thank you very much and God bless you all.